When graphing a system of inequalities, we follow the same rules as when we graph a single inequality in two variables. It's just that we graph multiple inequalities on the same graph. And the solution area would be, or the feasible region would be, wherever the shaded regions overlap. So we start by getting all equations into slope-intercept form. So the first equation in example 1, x plus y less than or equal to 3, we need to move the x's, so subtract x from both sides. We would get y is less than or equal to negative x plus 3. And then we can graph that line. Now that means the y-intercept is 3, and the slope is negative 1. So we draw a line with slope negative 1 and y-intercept of 3. We draw a solid line since this inequality is less than or equal to. Now the second equation, let's shade first. Y less than or equal to means we'll shade below this line. And now the second equation. We move the x, so subtract it from both sides to get negative y is less than negative x plus 4. Negative y means that the coefficient of y is negative 1, so we divide the equation, each term, by negative 1. Since we divided by a negative, we need to flip the inequality, so now it's greater than instead of less than. We have y greater than negative x over negative 1, or negative 1x over negative 1 is x, and then plus 4 over negative 1 is minus 4. So here our y-intercept is negative 4, and the slope is 1. So we draw a line with y-intercept negative 4 that goes through with slope of 1. Now since this inequality is greater than, we draw a dashed line instead of a solid line, which shows that the points on this line are not going to be included in the feasible region. And now y greater than means we shade above this line. And the feasible region for this system is going to be all of the area that is shaded by both inequalities. So we'll shade this feasible region in yellow just to show very clearly what the region is. So it's everything that's below the red line and above the blue line. So it makes up this little corner of the graph. And it will be including the red line for that part of the area, but not including the blue line. Example 2, graph the feasible region for the system, including these 4 equations. First equation is y less than or equal to 6. So that is a horizontal line that goes through y equals 6. Since the inequality is less than or equal to, it'll be a solid horizontal line. Y less than or equal to means that we shade below that line. Next, y greater than negative 1 is again going to be a horizontal line going through y equals negative 1. This time, since the inequality is greater than and not greater than or equal to, we'll have a dashed line through y equals negative 1. Y greater than negative 1 means we shade above this line. Next, y less than 3/2 x plus 8. This time we start at y-intercept of 8, and the slope is 3 over 2. So we draw a slope of positive 3 over 2. So down 3, left 2 would give us a positive slope. Since this inequality is less than, we draw a dashed line through these points. y less than means we shade below this line. And the last line is x less than or equal to 3. This line is a vertical line at x equals 3. And since it's less than or equal to, this is actually going to be a solid line. And now x less than or equal to 3 means all the x values that are less than 3. So x values like 2 or 0 or negative 10. That means we shade to the left of this line. And now I know that this graph is getting kind of messy. The feasible region is the region shared by all of the 4 equations here. So that is the region that is shaded in red and green and purple and blue. And that is this region in the middle. So in order to be part of the feasible region, it needs to be included in all of the inequalities in the system. So the feasible region here is this quadrilateral shape in the middle of the graph.